Welcome to Mist Resonance Engineering Private Limited, the pioneer in vacuum generation and mist cooling systems since 1990. Located on the outskirts of Pune city, MREPL's modern production facility is spread over an area of 13,907 square feet.
Hi, good afternoon. My name is Sagar and I am from Thermal Control Business Update magazine. Today we are in Pune at the premises of Mist Resonance Engineering Private Limited. So Mist Resonance Engineering Private Limited was set up in the year 1990, and this company specializes into mist-based technology, which actually eliminates the requirement of cooling tower and spray ponds. So they have this very unique technology with which they cater to variety of industries. And it actually, the cooling tower and the spray ponds are not required. They cater to the process industry and the power plants.
500
Installations
in India, and also abroad we cater to about 10 countries.
Yeah. So that's a great achievement what they have right now. 500 installations with this technology and 10 setups across the globe. So today we are joined by Mr. Makarand Chitale, who is the director of Mist Resonance Engineering Private Limited. So Makarand is going to take us through the company's journey, and he's going to explain us how this technology has been doing wonders and he's been catering to the industry from around 25 long years.
Yeah, correct. So say I have completed about 30 years of my career. Okay. And to tell you, to start with, see, this company's technology is a mist-based technology, which was originally invented by my father, Mr. Makarand Chitale, right back in 1980s. And because of its eco-friendly nature and green concept, it got popular in many industries very fast. And the sugar sector especially adopted it. And even we had global installations. Right. So this technology of mist creation has been known since 80s. However, the industrial conceptualization was done by Mr. Arvind after say 84, 85. Okay. And then till date, like he was succeeded by my mother, Mrs. Madhuri Chitale. Till we joined, that is myself, I am Makarand Chitale. I am a chemical engineering graduate from Bharati Vidyapith, Pune University of 95-96 batch. So I joined the company in 97. So till then, she successfully ran the show, which was extremely difficult for a non-engineering background person. But it is her courage by which the company has reached these levels. And with the blessings of Mr. Arvind, we have more than 500 installations across the country, and we cater to many countries outside India. So this is the short journey of our company till now. We are blessed to have a very good team where we have general managers, DGMs like Amol Chavan, who has been involved with us since many years. And we are catering to almost all industrial sectors today.
So, one thing which is really very inspiring, and then before I could start my questions, it was very inspiring to know that after your dad passed away, your mother took over the reins of an company which is very different in technology, and being from a non-engineering background, actually she put her heart and soul in the business today. So what were the challenges she faced in the initial days in an engineering sector, which was actually not only non-engineering but also a male-dominated sector? So if at all you could get some thought, this will be really inspirational for every one of us.
See, when my mother started the business, it was early 90s, and it was not a very encouraging time for a woman to be in the business, especially when the business was totally focused in sugar sector. As we know, sugar sector has been a cooperation or a cooperative kind of body which is run by sugar technologists, and then it was very difficult because it had a political background. Yeah. So, however, because she knew a lot of consultants, being with my father, she also attended certain seminars, and in PRO, she's an excellent entrepreneur. Okay. So, what she did is she hired certain technical people, and she continued the business from 90 till 97 for 7 long years. Yeah, she continued the business. She ran the factory, and at that time, the basic challenges were to deal with the political people. So at that time, she was helped by one of our directors, Mr. Bhupendra Shroff, my father's very close friend. She was helped by him, and with that, she could run the show till the time I joined.
And today, you mentioned that she's also very actively involved in the day-to-day managing of the business, right?
Now she's 72, but she's heading the company. She's the managing director of the company, and complete administration is handled by her.
And where are your factories in India?
Our factory, we have right now 3 units. One is at like all the units are situated at the same road, that is the Satara road.
Okay.
Our unit 1 is at industrial area of Kelavde, which is about 5 kilometers ahead of Khed Shivapur toll naka, which we all know. And then all other 2 units are also situated at the same.
How big are the manufacturing facilities if you talk about number of workers and the acres, the land area, and what kind of products are manufactured there?
See, there are, as I told you, there are 3 units. In unit 1, it's a fabrication and an assembly kind of a unit, where also we have pilot plants of all the products we manufacture. Essentially, we manufacture 5 products. The first is the flagship technology of mist creation system, which is an alternative to cooling towers. Second is an induced draft fill-less mist cooling tower, which obviously does not use any fills and replaces most of the latest design cooling towers in same space. Along with that, we also have zero liquid discharge as one of our company products, for which we got industrial merit award of Parke Puraskar is a known Puraskar, so we got Parke Puraskar in 2016, and those ZLD systems are also part of our product. And with that, we have mist and cool fogging systems for atmospheric cooling and dust suppression. And AHU is our product number 5, which is the air handling unit, which is used to used for conditioning of the atmospheric conditions and the ambient conditions.
Which we typically see in the aircrafts as well.
Yeah, which we also see in aircrafts. We have big AHUs in malls, cinema theaters, and all that.
So let us now dive into the technology aspect of it. And we'll have some discussions and some questions about technology. So my first one is, you already mentioned about the fill-less cooling tower technology. So how has the industry responded to this technology of lately?
Yeah, so to start with, let me tell you that these cooling towers have been known since 1950s and 60s to us. However, earlier we were known with an open loop systems, but because of industrialization, there was a need of having closed loop, where these induced draft cooling towers came into picture, and which were all fill based cooling towers. That means what happens here is the fan, which is located at the top of the cooling tower, sucks air from the bottom sides, which are called as forced or induced draft cooling towers, and the water trickles from the fills, and the exchange of the heat and the mass takes place, which is the basic function of fills, is to give the required surface area to the water. So the developments the cooling tower people were doing is having modern fills which will not choke, because the basic design of fills, because it's a close water and air contact, whenever the water is dirty or whenever the ambient conditions have dust in air, these fills tend to choke because of inherent nature of these fills. It's not the fault of design. However, how the fills are designed, they have to make a close contact, and thus they tend to get choked. The salt also deposits on the surface of the fills, and the cooling tower starts working with a lower efficiency as the age grows. So the cooling tower which is working fine on day 1 will not function the same way on day 30 and day 60. The process or the performance deteriorates. So we were always thinking that what technology we can bring where this problem can be eliminated. where the idea of a fill-less cooling tower came into mind. Now, when we had this idea, the main challenge was to fit the cooling tower in the same horizontal space or the plot size, because today we are seeing that the industries are getting shrinked and people are going vertical. So there is no horizontal space available, and we have to compromise in the space. So the main challenge for our company was to invent a technology where we can fit the cooling tower in the same space. So from where this induced draft mist cooling towers concept started emerging, we took various trials at our factory in Pune. Then also we developed a model, and then we took its trial at Jayant SSK, which is a sugar factory near Pune. And then we put it in operating conditions for almost 6 months. After all the tests we were satisfactory, then we launched that product. To be precise, we launched that product in 2021 after COVID. The main success of these induced draft cooling towers has been the surface area required, or which is generated by the fills, are generated by our nozzles. So in case our nozzles do the function of fills to generate the required surface area and give the heat and mass exchange for transfer of heat from one side to another. So what happens here is the water temperature reaches very close to wet bulb temperature with a temperature drop of about 15 degrees centigrade, and that too at very less power. So this is how we have been working on the replacement of the fills, or the concept of this tower started from the fill-less kind of a scenario.
And how has the industry responded to this technology till now?
See, till now, the industry response is extremely encouraging. Initially, the response was slow, but as the installations grew, that means the first 10 installations took a lot of time, because people are habituated to having same kind of technology and repeating it. However, when these towers were installed and then they saw them running successfully, then it was very, very attractive for them, because for industry today in cooling towers, why maintenance comes is main reason is fills. Because they choke, you have to often clean them. And then there is a lot of replacement requirements also. When you have to replace the fills, you have to take a shutdown. That's a big downtime for production units, which are chemical, petrochemical, steel plants, which run 365 days a year without any shutdown. That's a big downtime for them and a loss in production. So people were immediately very happy to see it, and we showed the working installations. And from there only, big groups like Vedanta, which is the large alumina complex in Jharsuguda, they became our customers.
Now, without the use of these fills and fins, how does the induced draft mist cooling technology achieve cooling efficiency?
So as I told you, the work of fills is to increase the surface area or the heat exchange between air water. The same thing is done by using our nozzle technology. What happens here is, because we have developed these patented nozzles which are called as mist creator nozzles. But the size of the nozzle, outlet size, is more than 14 mm in diameter, and still it produces about 50 micron average particle size of water. So when the water under pressure passes through the nozzle, it breaks into tiny size particles and forms fine mist. The travel time required to form this mist is only 3 meters. So in 3 meters, it converts into fine fog of 50 micron average particle size, and that's how the more surface area is exposed to atmosphere. So the surface area what we get is about about 20 times more in comparison to what is generated by fills. So that this is how that is how the advantage takes place. And immediately it has got many other advantages also. Like, because there are no fills in the cooling tower, there is very, very low pressure drop across the system. That means a fan which has to drag air through fills now does not have fills there at all. So the pressure energy reduces immediately, and the power which is required to run that fan drops down by about 30 to 50%.
So in a way, it is as energy efficient as well.
Yes.
Okay.
It saves about 30 to 50% energy on fan power, and the pressure requirements here are extremely low. It hardly operates at 0.5 kg pressure, which is half a kg pressure, which is normally available in any industrial sector.
How does the government's recognition of mist resonance as an approved R&D center improve your ability to innovate and bring new technologies to the market?
Yeah, see, it is very good for an entrepreneur. Getting your technology or your setup recognized by government adds on feather in your cap, because normally what we do, all R&D is done at our own cost. However, now there is an agency or a government body which is ready to help you. Like if I'm putting a pilot plant today, then I can apply for loans or getting the money at very low interest rates, because we have received this recognition. Now that recognition was also not simple, because it involves top scientists of Government of India who are the authorizing body of this certification. But when their team visited our factory, they saw the facility and the kind of pilot setups we people have created. Then they gave us this certification. From the advantages which we will got, the advantages which we will get now is, or we have been getting, is one is adds on value to the product, because today our manufacturing facility is a recognized center by Government of India. So it is a recognition which you have got. Number two, whenever we have a big pilot setup for any R&D facility, we can apply for loans through this scheme at a very low interest rates. Now, if we import certain products for our pilot setup or specifically for R&D kind of a job, then there is exemption in the customs duty also. So these are the main benefits. Taken by the government as well. Yes. So it is a good thing to have, and it's a great recognition. We also feel proud that we are recognized. Let's talk about the ZLD, zero liquid discharge, where there are some industries which are with very high water usage. So how does your technology play a role there to minimize the water usage and support ZLD? First of all, for zero liquid discharge technology, what we want industry is whomsoever adopts it has to also operate it. Zero liquid discharge systems are conventionally known in all types of industries since many years, when government had this policy that if any new chemical plant or any process plant is coming up, they cannot discharge water to canal or river, mainly to protect the environment. But what happens is the conventional technologies which are used, multiple effect evaporators, they consume a lot of coal because they burn a lot of water by steam. Now, when you do that, then you need big setups. And more than capex, it is opex which is worrying. Large industries like Reliance, Vedanta Group, Haldia Petrochemicals, or many industries which have these systems can afford it. However, for a smaller medium scale of a plant, it is very, very difficult to operate it. Maybe they can have capex because it's a one-time expense, but operating expense they don't afford. And then they find out certain ways of operating it at a lower time where they can manage the OPEX. So we focused on how these small or medium scale industries can also have a zero liquid discharge system, and they can operate it 24 hours. So that there is really no contamination happening. So using the same technology of mist creation, because see, these are all evaporative cooling systems which we manufacture. A portion of water has to be evaporated in order to cool it. So we just reversed our technology. Here we do evaporation for cooling the water, and in zero liquid discharge system, we keep the same water rotating and getting sprayed and forming mist and evaporating a portion of it in order to achieve the concentration and reduce the water content. So this is how this zero liquid discharge technology was developed, using the concept of there is already available heat in the nature, because the ambient air in summer is available at a very high temperature. Even in the temperature are lower, the wet bulb temperatures are much lower than the ambient temperatures. So we are using that delta to generate that heat naturally and then evaporating it every time.
I mean, I was very inquisitive about this thing. So when you say about temperature, we have in the summers we have really great temperatures outside. So since you said you have installations outside of India also, how does this challenges come about the temperature? Because temperatures might, if you have an installation in Europe, there we see 17 degrees average temperature, vis-a-vis 40 degrees average in the Indian subcontinent during the summers. So does that pose a challenge? And if yes, how do you navigate through those challenges?
Yes, it's a very good question from you. It does pose a challenge. However, that is where our research and development wing activates itself. So, an installation which is to be installed in Europe will not be sized in the same way it is done in India. Yeah, so what we do is the sizing of the system is done differently, where the all ambient conditions which are available there are taken into consideration, and then every system is designed. Like the heat content which is available in India will not be available outside India, like in countries like Europe. If it's a non-tropical kind of an atmosphere, then we will have to design our systems accordingly.
Basically, then the systems are more geography friendly, if I would say. So typically, how much time and what kind of involvement of the R&D team goes in developing those systems? What is the time for actually analyzing the temperatures and then developing the system?
See, for any such critical requirements, we take about 3 to 4 weeks to submit an offer, because that is the time required to design a system and then to actually put it into commercials and then submit an offer to the client. And depending on the size of the project, then the cycle time can be 3 months to 6 months. That's when the system is actually implemented.
Sir, what challenges do you see in some industries where there are still reservations about replacing the conventional cooling tower and spray ponds vis-a-vis the mist-based cooling systems? So, and is the company industry embracing this technology, or how do we create an awareness that look, mist-based cooling system is a much more better alternative than the existing cooling tower system? So, any thoughts on this?
What happens here is, if you ask me 4 years down the line, this challenge for us was a huge challenge, because at that time the induced draft mist cooling tower technology was not existing. So the flagship technology of mist creation required more space. So the main challenge of implementing the technology was availability of space with the client. However, after the introduction of IDMCT, which is a short form of induced draft mist cooling tower we call, this challenge is met in a quite a satisfactory way. Like we have now models at different site conditions for different geographies, as you said. And so we have product for all your requirements. So now these challenges have started becoming dilute. However, still there is a resistance from certain companies, which is obvious, that changing from field technology to a non-field technology, how do we take risk of our plant operation? What are the consequences? What if it fails? So these obvious questions are there. So to cater the same, what we do is we educate the client. We take them to the installations where our cooling towers are working. For example, if a client like Haldia Petrochemicals wants to adopt my system, we request their team to visit Vedanta Alumina, where the system is already working. Or we request them to visit a similar chemical plant to what they are operating, where they can verify from the user whether the system is working fine or not, why they change the systems, what are the advantages, what are the pros and cons. So that is how we educate the client, and then it converts into business.
Could you elaborate more on how the maintenance of the entire system is done? What kind of maintenance activities are planned after the installation of the system? How frequently the maintenance has to be done? something about the maintenance of the entire system to ensure that the systems run very seamlessly.
Now, this is one of our USPs, that our systems require minimal maintenance.
Okay.
The systems are designed in such a fashion that they will not require a lot of maintenance.
Okay.
Principally, why? The moving parts are very low.
Okay. Yeah.
In our flagship technology, there is absolutely no moving part, zero moving part. However, in our induced draft mist cooling tower, there is fan, gearbox, which are rotating items. So what we do is, for a client, we also suggest him to keep some spares.
Okay.
Because, and then we give them maintenance schedules. With every system, we supply our O&M manuals also.
Okay.
So they are aware what maintenance to be done, what specific cares are to be taken. When the commissioning of the system is done, our engineer trains the team of the client how the cooling tower should be operated. And apart from this, our company follows one guideline of having a continuous touch with the customer.
Okay.
Yearly once, we or our engineers visit the installations at least once, even if there is no complaint from them. So this is how we keep in touch with all our systems, and we ensure that the systems are working maintenance.
How your company is integrating high pressure misting and fogging of air handling and dust separation in industrial environments.
Now this is our product number 3,
Okay.
which you are referring to,
Okay.
which is a fogging system. Now fogging system has many applications.
Okay.
Now you asked particularly about dust suppression. However, it has got many applications in humidification, at jute mills, at many textile units, then atmospheric cooling in your greenhouses.
Yeah. Okay.
So it has got many applications. So these dust suppression systems, which we call mist and cool fogging systems,
Yeah.
the system is oriented in such a fashion that it is designed mainly based on what is available at the site.
Right.
So a dust system which will be designed for a coal handling plant, it will not be designed in same way where it has, if it is a coal yard. Okay. So because there are different features of handling dust.
Okay.
Now size of the dust particle also matters. Like we have made certain installations in loading unloading chutes, what you call, in a power plant, where from like where the coal is dumped by the dumper.
Okay.
And then there are loading unloading chutes from where it is filled in the truck.
Okay.
Which is the main dust generating center. So there the systems are designed in a different fashion.
Okay.
Because continuously something will be moving in and around them.
Right.
And then how they are arranged in a coal yard are again.
So jute will possibly have more fine dust particles than coal.
See, jute we have to take care of machines. Because in jute mills there are machines for weaving and all the operations of the jute.
Right.
So for jute mills the systems are oriented in totally different position, and the automation which we do is also done in such a fashion that it should not happen that the particle becomes wet, or sorry, the material becomes wet. So we have to take care of that also.
In the industrial cooling towers, what trend you see in the next 5 years, which is emerging, which the industry can embrace? According to you, what is your opinion and thoughts on this?
Today the main challenge is availability of water. Now the ground source, the availability of water is depleting. In India, there are certain areas where there is no groundwater. Like in Chennai, if we go, then the groundwater is almost zero, and people are not able to use water cooled condensers. So now the latest trend of industry is to shift from water to air. So instead of water cooled, there will be air cooled cycles which are available. So I'm not saying that air will totally replace water. It is not possible. However, the air cooled systems will play a vital role in all kind of industries which are being put up, and especially in water scarce areas. Like I mentioned, Chennai, then Rajasthan, there are many parts where there is a very low groundwater. So our company is also now focusing on how we can develop air-based systems where the requirement of water is zero or less. So we are focusing on building certain hybrid systems which will use air as well as water in less amount and do the same purpose which our mist cooling technology is doing.
The installations, whichever you have now, are there any areas where this kind of challenge is already there, where the groundwater is absolutely not there, or maybe the groundwater's quality, the pH or the contamination levels are high? This can be an interesting case if at all you could refer, or some of your project which is actually ongoing in any of these particular sites.
Yeah, see, now this problem mainly has been faced by us in Chhattisgarh. In Chhattisgarh, we installed our mist cooling systems for their power plants. That has been working since long time. Like Nakoda Steel is one of our very valued client since 2014-15. Has been using our water-based cooling tower for operation of his power plant. And now the problem is it is very hard to get makeup water, which is required for these water cooling towers to operate. So now their challenge is, what do they do? So we are implementing a project, or we are at a conceptual stage where we can have a hybrid system where they can use their turbine or operate the turbine at the same efficiency with use of water as well as air, where we can give them a kind of an hybrid cooling tower where they can run their turbine without drop in efficiency. Because what happens with air is, if you go for 100% air, then in summer when the air temperatures go up, the efficiency of the power plants will drop. So we are trying to develop a system for them. It is at a pilot scale now, and we are confident of developing this product for them in a short course of time. So these are the solutions how facing the challenges. And this is a live case of Nakoda Steel, which we are already working for them, where we can give them a techno-economical solution.
For example, if an air in a certain area is, let's say if the temperature is around 15 degrees, if you if we are talking from the Indian perspective, and we go to, let's say, up north in the winters, and there the temperature is around 7 degrees outside temperature, so will that really aid the air based cooling systems? How is it like?
Yeah, you are true. See, here what happens is, when you go to Himachal, the air temperatures are lower. So it will aid the air-based systems. They will not be as efficient as water-based anytime, because the wet bulb temperature will represents the moisture temperature which is present in the air, will always be lower than the ambient temperature. So in Himachal Pradesh, there is no water scarcity. So it is hard. It is very hard that they convert to the air systems. However, in Rajasthan, although ambient temperatures are very high, they don't have water to use. Like, they have no option but to go for an air-cooled system.
Okay, with that we come to the wrap of this small discussion with you. So anything apart from what we spoke, do you have anything to share with the industry, or anything which you might feel it's additionally required for the industry to actually gear up and use these systems?
See, there is one thought which I always had in my mind since early days of my career. You see, this industry, our type of industry, mainly which is a process industry or a power plant, is strongly driven by consultants. So it is my humble appeal to all big consultants like EIL, let it be Uday, or let it be Avantagarde, to be open for the technologies where they can themselves evaluate the efficiency by visiting the installations which people have. And then the industry or the revolution industry will actually take place. Because when we are approaching an end user, there is a limitation. However, if the consultants are open to many ideas like what we have, or many other companies do have these ideas which are revolutionary, but however there is a resistance from using the conventional technologies day by day, year to year, there should be an open platform available from these consultants for development or hearing out these technologies and actual implementation to the industry level.
Okay with accepting the change or embracing this technology? Do they have any reservations for not accepting this technology and not actually consulting them with their clients? Where is the stuck up?
You see, I'm not saying that all consultants are like that.
Okay.
However, what happens is whenever a new technology comes, then they will demand for similar installations. Now, the installations will not happen if they are not recommended.
Right, absolutely.
So this is how an industrialist like us have to start from the small. So when we directly approach the end user, we have to convince the end user, and then only the technology is adopted.
Right.
So if there is certain platform available for these consultants where they hear out new technologies and then actually try and implement in some of their projects, maybe on a small scale basis, it will revolutionize our industry a lot.
Okay.
That is our thought process.
So with that, we come to the conclusion of this small yet very interesting and very insightful chat with you. That was Mr. Makarand Chitale, who took us actually very easily to the journey of adopting mist-based cooling tower systems and how it can be effective in a contrast to the conventional cooling tower systems. So thank you, Makarand, for speaking with Thermal Control Business Update magazine, and we wish you best of luck for your future journey and for the new technologies which you are planning, which are also in the pipeline. Thank you so much.